So I want to walk through an example of how to calculate, not only how to calculate a confidence interval in Excel, but also a nice way to lay things out so that you can reuse them as a template. And I'll get into that more once we have everything filled out. But you can see here in this spreadsheet tab, I have, or this worksheet, I have what we ultimately want to get to with our data. And I'm using exercise 20.38 as sort of the example here. And we're going to go through 20.48 doing the same thing. And then we're going to do a different type of calculation using proportions as well from chapter 22. So I'm going to go to a blank tab here that I've basically imported the data, which you could either type in or copy or import from the CSV file, however you get it in here. This is the data as it was given to me from the book. So you can see it's not sorted or anything. Now I have actually have some formatting applied to this. I'm just going to clear this formatting so you can see what it looks like without the formatting. I'm also going to just clear this filter out. So this is really, if you were to import the data, this is what it might look like. What I do is I tend to select the data and actually give it a little bit of format just so that, it's just a little bit more readable. And to do that, I go to the Home tab. After I've selected the data, go to the Home tab, go to Format as Table, and now I have all these tables that I can select from. I'm just going to pick the simplest one, which is up on the top. And you can see here, by doing that, I have banded rows now, so it's a little bit more, it's easier to read. I'm just going to go through and actually just center this. It's not necessary, but I'm going to center it. And what I like to do is it's not sorted right now, ascending or descending. What I like to do is keep the original data set the way it is, and I copy using Command C or Control C, or you can just right click on here and say copy, and then I'm going to paste this data right next to it. And now if I want to sort this data, so it's exact same data side by side, if I want to sort the second column, I can go to Data, the Data tab, and I can do Filter, click this Filter button, and you can see this little caret comes up. And now if I click the caret, I can do all kinds of stuff. I can actually filter the data, I can sort it. I can sort by color, so I can apply some rules to it, but I'm just going to sort it from smallest to largest. The reason why I do this is so that I can very quickly look at my min and my max, kind of see what the data distribution is, and all that happy stuff. So now I'm going to unhide some tabs here. And I'm going to hide a couple of them just so that we don't look at them just yet. And so I see the data. The next thing I'm going to want to do here is just do a quick stem and leaf plot or chart the data. So that's my step 2. And in this case, we can do 2 different stem and leaf options. This is option 1, where we just take the anything to the left of the decimal point is a stem, and anything to the right is a leaf. And we just have 3 sort of buckets of data. The second option that I can use, and I'll just unhide here, is, and I'll just keep this unhidden just for the sake of brevity here. The second option is here, I've broken it, the 0, which is here on this row, I've broken it into 2 rows here. And so half of the numbers are falling to the, on the first one, and the other half are on the second one. I could have, said this was 0 to 5, and this was 5 to, or 6 to 10, either way, however you want to do it. But the bottom line here is that I can now see that it's single peaked in both of these. It's single peaked, and it looks like there's no outliers. But if there were outliers, we'd want to calculate sort of the threshold for outliers. So to do that, we're going to need to do the 5-number summary. And I've just sort of laid out some of the key components for not only the 5-number summary, but also calculating some of the outlier thresholds. So n is our sample size, and we can do that by using the count function, so equals count. And then I can just, and I'm going to use the original data set here. I'm just gonna make these, make these a little smaller here, just so we can get everything into one screen. So n here is going to equal count, and it's going to be the count of my original data set here. So I'm going to select the data set and hit return. So my count is 11. My average, or my x bar, is going to be equal to average. That's the function I'm going to use. And again, I'm going to select the data set. And so that now calculates my x bar, or my sample mean. Sample standard deviation, likewise, is standard deviation. Now I can do the S, the sample standard deviation here. Population standard deviation is the dot P, or I can just use the old way of doing things, which is just standard deviation. And now I can select my numbers, or my range, and I get my standard deviation here. Min, same thing, I can do equals min, and now I select my data set. So sort of the same process no matter what you're trying to figure out here. I'll do my median, so that equals median, and again I'll select this data set, and you notice I'm selecting the original data set, and that's just in case I made a mistake. I don't want it to propagate through everything. And I'll do my max, which is here. Max is going to be the data set as well. And so now I just need to get the Q1 and Q3, the first and third quartile. To do that, I can do equals quartile, EXC, and I'm going to select my array. And now I'm going to say 1 for the first quartile. For the third quartile, I'm going to do the same thing. But in this case, after I select the array, I'm going to select 3 as the number that follows to represent the third quartile. So there are my numbers. This is my 5-number summary right here, and then some other key components. So now I need to figure out what the outlier thresholds are. So what's the, if something's lower than some threshold or higher than some threshold, we can consider it an outlier. So to do that, I need to figure out what the IQR is, or the interquartile range, which is going to be Q3 minus Q1. So equals Q3 minus Q1. And you can see that's 0.6. Now, something that Excel likes to mess around with here is it's automatically populated some of these fields, and you want to undo these calculated columns. You don't want that to happen, and so it'll give you that option. It'll give you this little drop down here to do that. It's just trying to be super smart, and when in fact it's actually a little super annoying. So now I need to figure out, this is my IQR. I need to figure out the low and the high of the threshold. So to do that, if you recall, the low is going to be the first quartile minus 1.5 times the interquartile range. And my high threshold is going to be Q3 plus 1.5 times the interquartile range, which is 0.6. And so our range here is anywhere between negative 0.1 and 2.3. And so nothing lies outside of that. So I think we're okay. So the last thing we want to do is figure out what the confidence interval is. I'm just expanding these so you can actually see the text. So the confidence here, we're going to determine 90% confidence in this case. So we're going to say that this is 0.990. So that's our 90% confidence. And we need to figure out what the margin of error is here, or the SE mean is. And so to do that, I'm going to do a confidence T for a T distribution. And now the alpha is going to be 1 minus whatever we picked for our confidence interval. The standard deviation is going to be our standard deviation that we've already done, and the size is going to be the size which we've already calculated. And so I get 0.25 as my interval. And so my low is then going to be is going to be the mean, or the x bar. So the low is going to be x bar minus this interval. And the high is going to be x bar plus this interval. And so I get 1.92 to 1.42, which is my low and my high for my confidence interval. So essentially what we're saying is 90% of the time, if we were to take a random sample of 11 individuals, we would the mean would likely fall somewhere between 90% of the time between 0.92 and 1.42.